Mm, mm. Okay, so right here we have all of our includes, Arduino.h, wire.h, the Adafruit for our OLED screen. These libraries allow us to communicate with the OLED display and provide the math functions for the temperature calculations. Let me move this serial monitor. Um, Close, make sure audio is working. Hello. I assume it's working. I don't see a bar. On the desktop version, it has the bar that shows that my audio is working. Oh well. All right. So the OLED setup, we have a screen width, screen height, and the address to the OLED display. This defines the OLED display size, the I2C communication address, and initializes it as an object. Hardware constants. Um, the thermistor is connected to pin 34. The analog to digital reference voltage for ESP32 is 3.3 volts. Uh, the ESP32 is a 3.3 volt logic controller, whereas like Arduino is 5. Um, and the ADC has for the ESP32 has 12-bit resolution, meaning the values are from 0 to 4095. Then we have our fixed resistor, our beta, temperature in Kelvin. Yeah, the thermistor resistance at 25 degrees Celsius. And then calibration. The beta constant describes how the resistance changes with temperature. Calibration, the offset for getting the multimeter and the ESP32 thermistor was about 15.1 degrees. Um, just used to match it and the multimeter. The averaging function is this here. So sum here plus the analog read pin and a delay. This function reads the ADC multiple times and averages the result to reduce noise. We have a sampling of about 50, I think. Um, then return. This converts the average analog to digital value into a voltage. And the temperature calculation, this is important right here. Voltage, average, therm pin. First, the voltage is measured from the thermistor. The current is calculated here using Ohm's law. The current through the resistor and resistor calculation. Go our therm right there. Our beta equation, which converts resistance into temperature in Kelvin. And our roll unit conversions, degrees Celsius to Kelvin, and then Fahrenheit to Celsius. And apply the calibration offset. just to improve the accuracy. Show OLED there. That's what we'll be displaying to the OLED screen. The calibrated Fahrenheit temperature is displayed prominently. This is the very first one. And then display, print, Vout. And display therm right here and right here. Additional values like voltage and resistance are displayed for debugging and user verification. We have a setup function, void, no, actually right here. And the serial begin. The baud rate, analog read resolution of 12. Um, the serial communication, analog to digital settings, and I2C interface for this display are initialized here. We have a loop function, void loop, and then compute temperature inside of there continuously. Somewhere, um, serial print, no, compute temperature. Where is it? Oh, right here. So it runs off a Boolean. Um, the values are printed to the serial monitor and plotter, as shown. This plotter and serial monitor. We have the serial monitor down here with temp and Fahrenheit, the roll temp, the Celsius and voltage, Vout, R therm. Um, and show OLED. Oh, right here. So that's what is continuously updated and displayed. If the voltage is invalid, the system displays an error with the if statement. It's if okay. To prevent incorrect calculations, this code integrates the analog to digital conversion measurement, thermistor modeling, and calibration to produce accurate real-time temperature readings. Put my finger on the maximize it. Is a color code of our voltage, our temperature in Celsius, and then other features. I'll put my finger back on the thermistor, it'll rise and hold it really firm so it'll climb. But, it won't go past 100, I don't think. Yeah, we're at 88, 89. That's about as the max I'm getting. And that is the raw Fahrenheit temperature that's going over 100. Um, anyways, that explains the Arduino code. That's all for that.